Good afternoon, everyone. I welcome you once again to Dr. Ray's class. Now, let's together work on this simple problem on wave equation. The question says the equation y equal to a sine omega t minus kx represents a plane wave traveling in a medium along the x-axis, being the displacement at the point x and at time t. If x is in meters and t, which is time, in seconds, state the unit of k and omega, that's w. B says, what quantity does w over k represent? Justify your answer. C says, from the equation, what does a represent? What is the unit? And lastly, is the wave traveling in the positive x or negative x direction? Now, for us to have a better picture of what is going on, this is just a simple wave profile that shows the movement of the wave. I just want to briefly talk about it. This is the origin of the wave. That means where the wave started. The wave started from here as a traveling wave. That means it carries energy along. By the time the wave gets to this place, whose horizontal distance from the origin is x, and the time it took this wave to travel from the origin to this place is t. So they want us to use this information to answer the rest questions. Now let's go to the first part of the question. It says state the unit of k and w. Now I will go straight and tell you k, the name is wave number. And the unit is per meter, or you write it this way, per meter. Actually, the formula for wave number is 2 pi over lambda. That is simply to answer that question. Then the next one is the meaning of w. W is called angular velocity of the wave. The unit is radians per second, and the formula is 2 pi f, or 2 pi over period, because f is 1 over period. Now, this is just to go straight and drop the answer. Now, to understand more what happened, you need to remember the progressive wave equation generally is given as this: a sine 2 pi f minus 2 pi ft minus 2 pi x over lambda. This is the general wave equation. Now, all you need to do is compare this one with the one given in this question. Look at the one given in the question. It's written as a sine omega t minus kx. All you need to do is put this. You don't need to start proving it, because the proof is there, but that is not what we're doing now. Compare this, with the one given to you in the question. You see, in place of y, which is the displacement of the point, y is here. In place of a, you have a. This is sine, you have sine. Now go into the bracket. The whole of this is represented by this. Now, the whole of this represented by the whole of that. Minus is here, minus is here. So they are alike. What does that mean? In place of 2 pi ft from the general wave equation, from the one given to you, who is in that position? Omega t. If you divide both sides by t, this t will cancel, this one will cancel. You see, omega comes out to be 2 pi f, which is what we said earlier. Now, how do you get that expression for k? You know, say from the original wave equation, you have that 2 pi x over lambda. From the one given to you, it is given as kx. There's x here, there's x here. Divide both sides by x. This x will cancel, this will cancel. What do we have? 2 pi over lambda, which is equal to k. You see? So this is how we got the unit as per meter, because 2 pi is ordinary number. Lambda, which is wavelength, is measured in meters. So 1 over meter is what we mean by per meter. And of course, 2 pi is ordinary number. Frequency is in hertz. Hertz is the same thing as radian per second. If you now remember that omega is theta over time. So angular distance is measured in radian over second. That's how we got the unit as radian per second. Now we've been able to answer comfortably the A part of the question. Now let's look at the B part. They say, what quantity does W over K represent? Now let's do that here. Let's do that here. Omega over K, what does it mean? It means omega divided by K. Earlier, we've shown that omega is 2 pi f divided by k is 2 pi over lambda. Of course, in maths, you have 2 pi f. When you change this division sign to multiplication, you invert the next part of the expression. So rather than 2 pi over lambda, we're going to have lambda over 2 pi. 2 is here, cancel. Pi here, cancel. We're left with f and lambda. So that means omega over k is frequency times lambda. And from your wave equation, you know that there's an expression that says wave velocity is equal to frequency times lambda. So that means this equation and this equation are the same. Frequency times lambda, telling us this is actually the velocity of the wave. So the fraction omega over k represents the velocity of the wave. And to justify means to prove, as we've shown here, that omega over k is actually the wave equation. Now we're going to do the C part of the problem. What does the C part ask us to do? From the equation, what does A represent? And let's do this very quickly. The equation says y equal to A sine omega t minus kx. This A here, look at this graph, is the amplitude. Either the maximum amplitude above or maximum amplitude below. Either you call it here crest or trough for a transverse wave. So A is the amplitude of the wave. It's as simple as that. You don't need to make it sound different or difficult. That's what it represents. This is the displacement of the particle. This is the amplitude of displacement. And this is the time the wave has traveled. This is the point at which you are considering with respect to the origin of the wave. Now, the unit of amplitude is meter. That's the unit of amplitude, meter. Now, the last part of this question, D, asks, is the wave traveling in the positive x or in the negative x direction? Now, this is a very simple question. All you need to do is understand how simple it is. Now, look at this expression. Anytime you have a progressive wave equation, the first thing you look at is this sign in the bracket. Is it plus or minus? If it is minus as given to us, it tells you the wave is traveling from your left going to your right. That means if this is a Cartesian sketch, here is plus x, here is minus x, and here is 0. So the wave is going from the left going to the right if it is minus. If we change this place to plus, what does it mean? It means the wave is going from the right to the left, going from the positive side to the negative side. So to answer the question, the wave is traveling to the positive x direction simply because the sign we have here is negative. Anytime you have positive, it means the wave is traveling from the right to the left. So I hope this will help you to answer these questions whenever you see them this way. If you have any comments, any question, please feel free to comment and send your email. We can discuss anything you like concerning this. Thank you so much.